Hi everyone, our topic for today is about velocity and acceleration. So in this video, we'll talk about the velocity and acceleration associated with a vector valid function. And then we will use this vector valid function to analyze projectile motion. Velocity and acceleration. As an object moves along a curve in the plane, the coordinates x and y of its center of mass are each functions of time t. So rather than using the letters f and g to represent these two functions, it is convenient to write x equals x of t and y equals y of t, so that the position vector r of t takes the form r of t is x of ti plus y of tj. So to find the velocity and acceleration vectors at any given time t, so consider for example this point P with coordinates x of t, y of t that is approaching this point Q with coordinates x of t plus delta t and y of t plus delta t along this curve C. So this curve C has this position vector r of t is equal to x of ti plus y of tj. That is, as delta t approaches 0, the change in the position vector r over delta t approaches the velocity vector. So this is the velocity vector at time t. So from the figure, as delta t approaches 0, the direction vector p to q, denoted by delta r, approaches the direction of motion at time t. So by definition, the change in the position vector r is equal to the difference between r of t plus delta t and r of t. So dividing both sides of this equation by delta t, so we have delta r over delta t is r times t of delta t minus r of t, or all over delta t. And then taking the limits of both sides, so we get limits of delta r over delta t as delta t approaches 0 is equal to the limits of r of t plus delta t minus r of t all over delta t. So when the limits of this quotient exist, then this define the velocity vector, or called as the tangent vector to the curve at point P. Okay, note that this is the same limit used to define the first derivative of r of t. So the direction of r prime of t gives the direction of motion at time t. Moreover, to calculate the speed of the object at time t, we have to obtain the magnitude of the vector r prime of t. So by definition, the magnitude of r prime of t is equal to the magnitude of the vector with components x of ti plus y of tj. So this is equal to the square root of the square of the first component plus the square of the second component. And this formula is called the speed of the object at time t. Okay, so similar to how we obtain the first derivative of the position vector r of t is used to find the velocity, so you can also use the second derivative of r of t to find the acceleration. So by definition, if x and y are twice differentiable functions of t, and r is a vector valid function given by r of t is x of ti plus y of tj, then the velocity vector, the acceleration vector, and the speed at time t are defined as follows. The velocity denoted by b of t is the first derivative of r of t, which is equal to x prime of ti plus y prime of tj. The acceleration denoted by a of t is the second derivative of r of t, which is equal to the second derivative of x of ti plus the second derivative of y of tj. Okay, the speed is the length or the magnitude of the velocity, which is equal to the length of the first derivative of r of t, which is equal to the square root of the square of x prime of t plus the square of y prime of t. Okay, so similarly, in three-dimensional space, if r of t is defined as x of ti plus y of tj plus c of tk, then the velocity is defined as the first derivative of r of t, which is equal to x prime of ti plus y prime of tj plus c prime of tk. Okay, for the acceleration denoted by a of t, this is the second derivative of r of t, which is equal to the second derivative of x of ti plus the second derivative of y of t times j plus the second derivative of c of t times k. Okay, the speed of the velocity is the length or the magnitude of b of t, which is equal to the magnitude or length of r prime of t, which is equal to the square root of the square of the first component of velocity plus the square of the second component plus the square of the third component. Or this is the same thing as the square of x prime of t plus the square of y prime of t plus the square of c prime of t. So as an example, suppose we are asked to find the velocity vector, the speed, and acceleration vector for the particle that moves along the plane curve C defined by this position vector r of t, which is equal to 2 sine t over 2i plus 2 cosine t over 2 times j. So to find the vector, the velocity vector of this position vector r of t, so we need to find the first derivative. Okay, the first derivative of r of t denoted by r prime of t is equal to 2 times the derivative of sine is cosine u times the derivative of u. But derivative of sine is sine of t over 2 times the derivative of t over 2 is 1 half. Now times 2, so you cancel this out. So you have cosine of t over 2 times I. Minus or plus the derivative of the second component. So you factor out 2, then get the derivative of cosine. Recall that derivative of cosine u is negative sine u. So you have negative sine u, where u is t over 2 times the derivative of t over 2, which is 1 half. And 1 half times 2 is 1 times the negative of sine of t over 2 times j. So therefore, the velocity for the particle that moves along the plane curve C described by this position vector is equal to cosine t over 2 times I minus sine of t over 2 times j. Okay, for letter B, for the speed, we simply calculate the speed by taking the square root of the sum of the square of each component. So this is equal to magnitude of r prime of t is equal to the square root of the square of the first component. So you have cosine squared of t over 2 plus the square of the second component, which is sine squared of t over 2. But recall in trigonometry that sine squared theta plus cosine squared theta is equal to 1. So therefore, this whole expression is equal to 1 and the square root of 1 is equal to 1. So therefore, the speed of this plane curve C defined by this position vector r of t is equal to 1 at any time t. Okay, the last is we need to calculate the acceleration vector, or we need to find the acceleration vector by taking the second derivative of r of t. So we define a of t is the second derivative of r of t. So if this is the first derivative, the second derivative can be obtained by taking the derivative of the velocity. Okay, recall that the derivative of cosine u is negative sine u times the derivative of u. Derivative of t over 2 is 1 half. So that's why this is negative 1 half sine of t over 2 times I minus the derivative of sine u is cosine u times the derivative of u. Derivative of t over 2 is 1 half. So we have negative 1 half cosine of t over 2 times j. So therefore, the acceleration vector is negative 1 half sine of t over 2i minus 1 half times cosine of t over 2j. So in summary, to find the velocity, acceleration, and speed, now we need to follow this formula. The velocity is just the derivative of the position vector r of t, which is defined as r prime of t. The acceleration is just the second derivative of r of t, denoted by this notation. And the speed is the length or the magnitude of the velocity, which is defined as the magnitude or the length of the first derivative of r of t.